3 squared, u to the negative 2, v to the power 2. Oops, need a bigger bracket than that. Okay. I like that people are asking varied questions. This is a beast of a question. Right? For the people sitting at home, I don't want people overwhelmed and thinking, oh God, the entire first quiz is going to be all of these questions and it's multiple choice, so if I even slightly screw up, I'm screwed for the whole course. Now, this is another one that I would classify as like really hard. Like maybe one of these on a term test, but this is a hard question. But nonetheless, let's go through it. We're going to go through it slowly. And again, the properties you apply might be slightly different than mine. I do things in an order that makes sense to me based on how I've learned exponents. Okay? That doesn't necessarily mean that the way I learned exponents is going to be what's best for you. But let's go through this. Okay? Now, the first thing that I see is 3 to the 2, 3 to the 2, 2 to the 2, 4 to the 2. So just to get myself feeling kind of good, I might simplify those real quick. Right? 9, 4. Okay. Another 9. And then 16. Right? Now that's just my first instinct. It may be that I get through the whole question and, in 5 steps I realize, oh, that was a bad idea. Maybe these were left as exponents for me to use some of the rules. Okay? But right away, I'm just feeling a little more confident because, hey, I know how to do those. I know those calculations. Okay. So u to the negative 2, v to the 2, u to the 3, v to the negative 3. Okay. Now, what else catches my eye? I do see these exponents outside the brackets, so there might be something I should be doing with them. Okay. But I also see it's really complicated going on inside the brackets, so maybe we pay a bit more attention to those. Because I also notice I'm writing a lot each time. Maybe there's a way to simplify things a little bit. Okay. So I might notice here I've got 2 different powers of u. Okay. And they're being divided. So again, think for a moment. What happens when we divide powers of the same base? Right, what's that rule? Okay, a to the x over a to the y. That's a subtraction. So maybe I could turn this into a subtraction and just get a single u here. Something to think about. Okay? And while we're at it, I've got some v's here. I could do the same sort of thing there. Right? Now, if that's not your first instinct, that's okay too. But it's definitely a thought that I'm having here. So I'll keep it with a 9. I'll keep the 4 on the bottom. But now u to the negative 2 divided by u to the 3. I'm just going to subtract this 3 here. And v to the 2 subtract negative 3 here. And then that's all being raised to the negative 2. Okay. And then, well, there isn't a whole lot going on here with the other side. Okay, so we'll just leave it as is for a moment. Okay. So what else? Well, I suppose with the -2 and -3, I could change that to a -5. And the 2 minus -3, that's going to be 2 plus 3, so I could change that to a 5 as well. Okay. Don't you to continue to add the exponents 2 and 3? Yeah. Well, I assume you made that comment before I started doing that. I'm just trying to show things broken down a bit more than we might expect. As you master these things, yeah, what's going to happen is you're just going to say, okay, 2 minus -3, v to the 5. But not everyone has to be at that stage yet. And as long as you go through all the properties, you don't ever actually have to be at that stage with the mental math. Right? As long as you are able to work through the questions, you should do fine. Okay. So what else could we do? Well, I like that I simplified this a bit more. Okay. Just for personal reasons, I'm going to center this 4 a bit more. Okay. But all the u's are combined, all the v's are combined. Maybe it's time for me to deal with this to the -2 here. So that's going to be u to the -5, v to the 5. all over 4 raised to the power 2. Again, this trade out your minus sign. Okay, get rid of that at the cost of doing a 1 over. Oops, that should just be a regular U. And I haven't really touched this part here yet, so maybe we should expand these exponents here. Certainly a thought. Okay. But it's not the only thought we could have. Okay. I could actually just combine these two expressions by multiplying, and this part here would come onto the numerator. Okay. It's all about what you think will work, trying it out, and continuing to apply properties from there. But I'm going to go with my first instinct. Okay. What I'm going to do is I'm going to say, well, I've got some fractions here being raised to a power of 2 for this fraction, power of 2 for this fraction. Let's rewrite these as various things to the power 2. Okay. Got 1 over so 9 u to the negative 5 v to the 5. And then just a 4 down here, really. Okay. And then the other fraction, both parts raised to the power 2. Okay. 9v to the 5, 16u. Okay. And now, what else do we have? Well, we've got products in here being raised to some power. We could split this up even more. Okay. So we could split the top here, 9 to the power 2, u to the negative 5 to the power 2, v to the 5 to the power 2. And on the bottom, I suppose we could say 4 to the power 2 is 16. Although the numbers might be getting a little big, so we might want to stop doing that. We'll see. Okay. Similarly, we've got the 2 here can distribute over the product. Okay, 16 to the power 2, u to the power 2. That's the rule. A times b to the x is just a to the x, b to the x. Okay, we apply these when we think of them. And now, what do we see? So think about it for a moment. What do you see here? What might be a good property to apply? Yeah, I also hate u and v as exponents. Or in really just any algebra question. Actually, what's really bad, if we were in class, my a and my u can look very, very similar. I teach a course on vectors, and we use u's and v's all the time, and it's super annoying. Okay. So what could we do? Well, I notice I've got powers of powers. So this v to the 5 times 2, or v to the 5 to the power 2 is v to the 5 times 2. Right, so we could go ahead and rewrite that. V to the 5 times 2. And as you're getting more comfortable with this, you might not write 5 times 2. You might say 5 times 2 is 10. And hey, we got another v to the 5 to the power of 2 here. So we can get another v to the 10. Negative 5 times 2, we're going to have u to the negative 10. We could rewrite it all out again, or as you're doing your own work, you can just change these things and cancel them out. Okay. So what else could we do here? I definitely see a lot of, v to the 10s and powers of u. I want to start combining these. I also notice I've got 1 over a fraction. So we could use that little shortcut that I mentioned. I've even, I believe, mentioned this in a lesson, but 1 over a fraction, you just flip the fraction. Okay, that's sort of an unspoken real number property. So let's apply that here. Okay, so that bit can change to 16 over 9 to the 2, u to the negative 10, v to the 10. And we've got 9 to the power 2. I could write those as 81, but I'm seeing that those numbers are getting kind of big, so maybe I don't want to. Just like I could also, if I was comfortable, do 16 squared is 256. And it's u squared down here. But, oh, look at that. There's some powers of v, okay, powers of u. These things can be combined. How do we multiply fractions here? Well, we multiply things together. So 16 times 9 squared times v to the 10, just combining the tops. And then we also want to combine the bottoms. But u to the negative 10 times u to the 2, that's going to be, multiply things of the same base, you're going to add the exponents. Okay. So 9 squared, it's going to be u to the negative 8. Now we've got a lot of simplification we can do here because v to the 10 and v to the 10. 9 to the power 2, 9 to the power 2. Those things just go away. I've got 1 16 up on top. I've got 2 16s down on bottom. So I could cancel out one of them. And we're looking at something like this. The whole top went away, so we're just left with 1 u to the negative 8. And we've just got 1 16 down here. Okay. Now they said get rid of negative exponents in the question. I still, after all this time, still have a negative exponent. Okay, so what could we do? Well, we could try rewriting it, thanks to our rule. Okay, you notice I'm not mentioning the rule. We're getting a bit more comfortable with it. 1 over u to the 8 times 16. That's just going to be 16 over u to the 8. And then look at that. 1 over another fraction, we flip it. Okay, so after all our hard work, there it is. It's been a lot of properties. We're getting a little faster here at the end, just as we're getting more comfortable. But u to the 8 over 16. Okay, a lot of work, a lot of properties, but it is still doable. Okay, questions or concerns there at all? Okay, can you explain this part here? I'm confused what happened to the 1. Which one? If you want to unmute and ask me or try and get more specific with which one.
Yeah, sorry. I got a little bit lost at the end. Just when you added the 16 at the very top to the 9.
Mm-hmm. To the 9?
You added, like that.
Or this part here?
Together. No, the first one.
Okay. So the 16 and the 9? Yeah.
I'm just confused. Sorry, I got lost there.
Okay. So what's going on between this step and this step is we've got 2 fractions. This one here and this one here. You with me so far?
Yep.
Okay. So how do we multiply fractions? Right? We multiply fractions by multiplying the tops and multiplying the bottoms. So what have we got? We've got 16 times what's over here. So times 9 squared times v to the 10. I'm just not combining these numbers because I'm looking ahead and I see I'm going to cancel things out. Okay? So the 16 comes from over here. It just multiplies with what's over here.
Oh, okay.
Okay.
You just add it, you didn't add them together, but you put them together.
No, if anything, I would multiply them together. I'm just collecting them together there. But I see that I've got some 16s and some 9s, so I don't want to multiply them out and then have to divide them. Okay? Additionally, 16 times 81, that's a little cruel. That's 1,296, and it's very hard to do without a calculator.
Right.
Yeah.
And then the one at the bottom, so the 1 over 16 over u to the exponent 8.
Yeah. So that's the same sort of rule here. 1 over a fraction just flips the fraction. I believe this was mentioned at the end of the real number property lesson. It's just a nice common one that's useful. But 1 over a fraction flips the fraction around.
Oh, sorry, yeah.
No problem.
I didn't even notice that you flipped them. I'm sorry, yeah.
Oh, that's okay.
I got it. Thank you.
Anyone else have some confusion there at the end? Or, another part, hey, can you go back to the very second step you did? You lost me there. Can you re-explain that part?
Just curious.
Yeah.
The 1 over u to the 8 times the 16, the third to last step.
Yeah, this part here? Yeah.
Yeah. You lost me there.
Okay. Yeah, I had a feeling that might lose some people because, okay. So let's rewrite this a little bit. Okay. So I'm going to ignore the 1 on top if that's okay with you. We're just going to deal with this part here. The 1 over u to the 8 times 16. So how do you do this? Well, you've got to combine fractions, right? Except it looks like we only have one fraction. 16 is not a fraction, it's a whole number, right? And this is a great trick in math. we can rewrite all whole numbers as fractions. What's the difference between 16 and 16 divided by 1?
Yep, I got it.
And,
There we go.
and then there, so it's another sort of shortcut, just like the 1 over a fraction flip things. If I see a over b times an integer, okay, you know, a over b times c, it's just ac over b. Okay, it's sort of another quick thing. And I do apologize when I do that, because again, I'm very comfortable with this, and I don't know exactly what the best way to break everything down for everyone is. So I'm glad you stopped me and clarified that, because I'm sure you were not the only one having a bit of an issue with that.